AROA's patented like steel fiberglass rock bolts are designed for use in underground coal mining applications to reinforce tunnel walls. The unique high-torque characteristics of these bolts provide equivalent ease of installation to steel rock bolts. At the same time, they're designed to be fully cuttable, preventing damage to mining equipment such as shearers and conveyors during the major coal extraction phase. On the non-mining side of an underground coal mine tunnel, conventional steel rock bolts are used to support the tunnel roof and walls. Expensive mining equipment can be easily damaged if these steel bolts are used on the mining side wall of the tunnel. Therefore, the use of cuttable fiberglass bolts, which can be easily broken up and thus preventing damage to equipment, has become increasingly accepted. Steel bolts used in coal mine tunnels are easily installed and have deformations or protrusions which act to mix a two-part resin together, bonding the rock bolts to the rock strata, a process known as encapsulation. However, a major issue with fiberglass bolts has been inadequate bonding of fiberglass bolts to the coal strata during resin encapsulation. Encapsulation failure, known as gloving, occurs when the two-part resin capsules are not completely broken open, so the resin and catalyst are inadequately mixed together. Torque strength of fiberglass bolts has been another major issue, with fiberglass rock bolts in the past not having the torsional strength of steel bolts, and thus being prone to breakage during the installation phase. AROA's like steel high-torque range of fiberglass rock bolts overcome all these major issues. Here's how. First, let's look at the encapsulation issue and how AROA's like steel rock bolts overcome this. The AROA like steel bolt, with a washer plate and AROA torque nut attached, is placed part-way into the hole until it engages the resin capsule. A drill attachment with a socket attached is then used to spin the bolt while being pushed further into the hole. This spinning action breaks open both parts of the resin capsule and mixes these components together. The bolt is then held steady for about 10 seconds until the resin hardens, encapsulating the bolt and bonding it into the coal strata. The nut is then spun further to tighten the bolt and put load onto the coal strata. To prevent the nut winding down the thread of the bolt during the spinning operation, AROA's torque nut has a breakout cap strong enough to resist the spinning torque, but which can be easily broken out when the resin hardens. Unlike AROA's like steel fiberglass rock bolts, when using conventional fiberglass rock bolts, all too often the encapsulation fails due to gloving of the resin capsule. When gloving occurs, the partially broken capsule casing migrates up the smooth bolt shaft, preventing a full bond between the bolt and the coal. Alternatively, the bolt may fail to completely break open both capsule casings, preventing the catalyst from reacting with the resin. Both these types of failures, when using conventional fiberglass rock bolts, can be complete or in part. However, AROA's patented like steel rock bolts are designed to deliver optimum encapsulation every time. Firstly, a hollow-tip sharpened end point locks onto the capsule, then pierces the capsule casing, allowing the resin and catalyst to be mixed together. The shank tip end of the rock bolt has 3 mm projecting vanes. The effect of these special vanes is to produce a large 25 mm spin diameter, forcing the capsule casings down into the back of the hole, fully separating the resin and catalyst from the casings, then completely mixing these components together and guaranteeing high bond load transfer. The tapered shank end of the bolt reduces the pressure in the hole, allowing the now mixed resin to travel up the shank and complete the encapsulation. 2 mm mixing and bonding projecting vanes continue the mixing process while allowing the resin to continue traveling up the shank. Only the AROA bolt is made using a patented process which molds the bolt with a thread and deformations or protrusions similar to a steel bolt, and giving a huge shank torque strength of 320 Newton meters. The patented AROA process ensures that the glass reinforcing fibers are properly distributed throughout the bolt, ensuring maximum nut thread strength and resistance to torsional forces. In recent years, modern coal mine tunneling equipment has developed significantly and now incorporates powerful hydraulically operated drilling rigs. During installation, this machinery can easily damage traditional fiberglass bolts. On one occasion, this resulted in a serious incident and a subsequent state government mine safety authority warning miners about the use of fiberglass bolts. Only AROA like steel high-torque fiberglass rock bolts have sufficient torsional strength of 320 Newton meters to resist these high-torque forces and prevent damage to the bolts during installation. Only the AROA like steel high-torque rock bolt has a nut thread strength of up to 10.5 tons. Only AROA like steel fiberglass rock bolts offer the same ease of installation as steel rock bolts while being easily broken up by shearing equipment and therefore do not damage conveying equipment. Only AROA fiberglass rock bolts provide the unique combination of full encapsulation along with high torsional strengths, meeting your requirements for lightweight for easy installation, reliable encapsulation, resistance to torsional damage, high load transfer and head strength, achievement of ground engineering specifications.